This is Pre-Calc Unit 4.3 Conics section notes. This is kind of the bare bones of conics. We're going through this kind of quickly, and so we're not finding the foci and those different things. So if you're looking for that, this is the wrong video for that. And so what we want to do starting off is just play around a little bit. So if you look at this, I have this link here, this little Google short link. Plug that in, and I want you to go to Desmos and start looking at conic sections. And so if you click on that, you'll get this website. And now what I want you to do is start playing with this A value. See what happens as A gets bigger for what we're doing here. And also when it gets, negative, look at that shape. What shape is this? And if you can tell, what shape is this one over here too? And play with your A's and B's and C's and D's and try to figure out what's going on here. Pause and do that. Done playing? Okay, so what we want to do then is try to answer some of these questions. What happens when A is equal to B? So if I take this and I make A equal to B, what shape do we get? Well, that looks like a circle. So that would be one of the conic sections. Let's see if that works for everything. Well, and I'm not going to do everything, but there's another example. So A equal to 4, B equal to 4, that would be a circle. So right here, you would write down circle. What happens if A is less than B and not different signs? Well, we get this shape here. Which way is it orientated? Is it orientated east-west or north-south? We're going to say the longer axis is going to be east-west. This is an oval shape. Does anybody know what that's called? Oh, some of you know. It's an ellipse. So classify that and see what that is. And then see what happens if A is greater than B. What happens to your general shape? Which way is that running? Okay, and then try these other ones and come up with some facts about them. Pause and do that. So I'm looking at this, A equal B is a circle. A is less than B, we get an ellipse that's running east-west. A greater than B, we get an ellipse running north-south. And that's the name of this oval, is an ellipse. And then this one, A and B are opposite signs. When that happens, we get what we call a hyperbola. And so we either get north and south like this, or we get east and west going like this. So this is what we'll call east-west. This will be a north-south. And then the last one, if we don't have both terms squared, we just have one of the terms squared, then we're going to end up with a parabola. You should be very familiar with those. Now, I just did one of these going up and going up. You could have a leading term that was negative, so this would be going down, or vice versa over here too. But if B is 0, we're going to get a left-right orientation. A is equal to 0, we're going to get an up-down orientation. And what do C and D? Did you play with C and D and change those on the Desmos? You're going to get a left-right orientation if C changes, and then D is going to make it up-down. I really encourage you to play around with those things and try to figure out what's going on. So what we just entered is the world of ellipses and conics. And why do they call them conics? Well, if we place two cones, one above each other like this, if we cut those cones with a plane, like we have right here, then the resulting figure, I don't know if you can see that in there well enough, but that would be an ellipse. If this cone was cut straight across like this, then you would end up with your circle because it's symmetrical cut with that plane. I'm not going to be able to draw that for you, but that's the idea. The parabola would just cut one of these cones and go off into space, and then the hyperbola would cut two of the cones. And so those are the shapes that we end up with. That's why we call it conics, because they come from a couple of cones. Now let's try to classify each one of these in a simpler form. So in other words, I gave you this conic form. This is the conic form of an equation of a conic. But we can get in more specific forms that are center-based or vertex-based. And that's what we want to start looking at down here. So I'm going to give you big notes you're going to put in circle in each one of these, or ellipse and then parabola and then hyperbola into each one of those spots. So fill this in and stop when you have to. On the circle, one of the equations that we can use is this one here. X minus h quantity squared plus y minus k quantity squared is equal to r squared. You should be familiar with this. This is a translated circle to the point hk. So that's the center. R is the radius. So the radius is for each point that goes from this center point out to the circle. HK is that center. This equation does come from the distance formula, and it is Pythagorean theorem essentially, but it's the distance of all points from a certain center that are just r units away from that. And that's a circle. Now what we can do is we can write this circle also in this form. I can divide this by r squared. And that's equal to 1. So this is kind of the general form that you're going to start seeing for the ellipse. And what happens is that if these bottom pieces are both the same, you're going to know that you have a circle, because your dimensions in the x direction are going to be the same as the dimensions in the y. We'll talk about that a little bit more later. But this is also another version of a circle. Okay? Now the next one, so you filled that into that little spot on your note sheet. Thanks. Your next one is going to be the ellipse. So here's the ellipse. If we go north-south, what happens now is that this is kind of the equation that I just showed you with the circle. However, what happens is that on the x-axis, we're going to go A units out. On the y-axis, we're going to go B units out. And so that's what we do. On the y-axis, we go B and negative B, and on the x-axis, A and negative A. So that's how you can draw these things very quickly if you have it in the ellipse form. Now this is where B is greater than A. So this is north-south, B is greater than A. What does that mean? Well, that just means that we're stretched on the y more because this value is bigger on the y. East-west, what does that mean then? Which one's bigger, on the x or on the y? Well, the x is bigger. We go out A here and A here, so A has to be bigger than B in this orientation. So this is an east-west orientation for our ellipse. This is the general equation. Notice it's the same for both. It's just which way do we stick out more on one side. Okay? So going back to the circle, my alternate form of the circle, you can see how maybe we just came in with one of those. Now this also can be translated, the ellipse. So what you'll see a lot is x minus h quantity squared all over a squared plus y minus k quantity squared over b squared is equal to 1. That's the general equation for the ellipse. I'm going to skip over the parabola, so you should be writing these things down, and then come back to that. So I'm going to do hyperbola because it's very similar to ellipse first here. So for the hyperbola, we'll have a north-south hyperbola, which looks like this. This is north-south, when my x value in this orientation is negative. So this equation is identical to the ellipse, but it's a hyperbola, and then one of the terms is negative. In this case, if the x is negative, we won't show up on this x-axis. We'll be on the b-axis. And so if you see this orientation right here, this would be the corresponding ellipse just built right in here. Oops, sorry. Would be the corresponding ellipse right in here. And so these are very similar, it's just how they're orientated. Now the other thing with this is that this vertex would be 0, b. And this one would be 0, negative b. Okay? So we have vertices for this as well, which is right there and right there. Those are the vertices for this. Now if we want to run east-west, what do you think's negative now? Well, if we're running east-west, what happens is that we get x squared over a squared minus y squared over b squared is equal to 1. These are east-west values. And so we're going to end up with things like this. This would be a vertex here. So the vertex for this one would be A0. This vertex would be negative A0. Okay, so that's on the X. Now the size of the X of the A and B don't matter for this one. It's just which one's positive, which one's negative. That will tell you if it's east, west, or north, south. For the ellipse, it's which one's bigger. That just stretches it out more. This one can also be translated. I'm not going to write that down here, but I can put this as X minus H and this as Y minus K instead of X and Y respectively, and then get a translation of this graph to different places. And on this note sheet down at the bottom, I also have some individual ones to play with. These are the different graphs that you can go ahead and play with for circles, parabolas, ellipses, and hyperbolas. You'll get a much better understanding if you play around with HK and the different values for A and B as well. Okay, so try those when you get a chance. So now I'll go through these examples. This is example number 1. I'm not going to do this justice on this small thing, so I'm going to go on a bigger piece of paper here. First of all, what shape do you think this is? Well, you should know that it is a circle. Okay, so this is the general form of the circle, which we had from before. Now, if we look at the center, we can find the center by finding out which value of X makes this 0. Well, the value of X that makes that 0 is negative 3. What value of Y makes this inside this parentheses 0? That would be 2. So that would be the center of your circle. And that's what I have right here. X minus H. So that would be X minus a negative 3. So we get that. And then X minus 2. Yep, you got that. Then what's my radius? Well, remember that this is R squared. So what is R? Well, that would be 4. And we don't go plus or minus 4 on this one because we're talking geometry. And so it's just 4 for a radius. So in the X direction, we get a 4. In the Y direction, we get a 4. I think this is obvious. But when we get to ellipses, then you'll have to be looking at what happens in the X direction and the Y direction. So if I graph this, I plot my point. My center is negative 3 and then 2. That's my HK. And then I'm going to have a radius of 4. So I'm going to plot 4 points. So I'm going to go in this direction 4, this direction 4, and then down 4 and up 4. So I went each direction 4, and so I can just draw my circle. Not going to be great, but not bad. Okay? So there's your circle from this equation. There you go. Now we'll move on to the next one. Example 2 here. So when we do that, we get this equation. Now, what shape is this? Well, according to all the graphs that we have, or the equations that we do have, I got all my papers here, sorry. This one would be an ellipse because I get x squared over a squared plus y squared over b squared is equal to 1. Now, if it's going to be north-south, then that means that b is bigger than a. East-west, a is greater than b. If I look at this, this value with the y is going to be a 5. This value with the x is going to be a 2. So when we look at, first of all, the center, oh, by the way, this is an ellipse. So when we look at the center of this thing, the center is going to be 0, 0. I do not have a translation on the x or the y, so 0, 0 is my center. Then if I look at my x extension, I'm going to extend out 2 on each side. If I look at my y extension, I'm going to extend out 5 on each side. So that's how I extend it out. What I like to do is build a box. And when I build a box, what we do is we try to fill that in with that ellipse. So we have this one. I should call it a rectangle, not a box. That's what you're doing in your mind, is building that box. I'll keep on calling a box, sorry. Building that rectangle right there. But then what I do is I build this ellipse inside. It should be nice and smooth. So there is my ellipse. This would be a north-south ellipse. It's not as important as the north-south hyperbolas, but you can just tell from the equation that I'm going to extend on the y more than what I'm going to extend on the x. How much? 5 and 5 in both directions, 2 and 2 in both directions on the x. And sure enough, that's what I did. This distance then would be 4, this distance here would be 10. So that's how you plot your ellipse. So now we got example number 3. Y squared over 4 minus x squared over 25 is equal to 1. Oh, it's the same. Oh, no, it's different. Oh, some things are changed around, so I got to be careful and figure out what happens with that. Well, if we have the minus in there, what's this one called? Well, this one is the hyperbola. And which way, how much do I go in the y direction? Well, I go 2. Which way do I go in the x? I go 5. So this is going to be different than what I did on the last one, but I'm going to build the box exactly the same as what I did last time, but with respect to the particular axes. So here I'm going to go up 5. And 5 and 5. And then on this axis, I'm going to go out 2. Now, how we do this is that we build the box like we were doing it for the ellipse. Except for now, what we do is we put and shoot a line through here. And I got to draw this way, sorry. Those are not our curve, or that's not our curve, but those are what we call asymptotes. That's what we use to approach. And since this y is positive, this is going to be a north-south. So it's going to be like that. And so my vertex will be on the edge of the box. You got to think outside the box. Don't go inside for the hyperbola. And so then what we're going to do is we're going to arc this, and then we're going to approach this asymptote. We're not going to cross it, but we're going to approach it. And then we'll do the same thing over here. So that's how you graph it. Down here, same thing. We'll approach here, and then you'll approach there. So this is a picture of my hyperbola with the y being positive. If the x was positive, then the vertex would be here going out, and the vertex would be here going out. If the x squared was positive and the y squared was negative. Okay, I'm going to let you try to figure out those other 3 graphs and try those. And then also I got to make a couple other videos, one regarding the calculator and graphing with the calculator, the conics. And then the last thing is completing the square. We'll have to do completing the square too in this unit, but that's the way it is. Okay, thank you very much. Have a great day.